Hello everyone, welcome to this next question on classical mechanics. In this video, we shall see question from June 2019 consisting of 4.75 marks. The question says, let Q and P be the canonical variables. That means you are given Q to be the generalized coordinate and P to be the generalized momentum. Then they are saying, consider the following transformations, and these three transformations are given to you in canonical variables. So you are to tell out of these three, which of these are canonical transformations, right? So this is what we need to tell in this question. So in order to start solving this question, what can we do? We have to see a result which based on this Poisson brackets. So the Poisson brackets of two vectors or two quantities x and y with respect to some q and p, that is given by del x by del q into del y by del p minus del x by del p into del y by del q. So this is the formula corresponding to this Poisson bracket. So for more information about on the concept of these Poisson brackets and canonical transformation, you could visit the video lectures on classical mechanics, whose link is given in the description, right? So here what we do, there's a property which states that if we take Poisson bracket for the canonical variables, whether we take it to be q and p or we take it to be the old coordinates, this q and p, it comes out to be 1 because this Poisson bracket remains invariant under transformation. So if this thing is true, then we say that our transformation, that is a canonical transformation. So right, so this is the result. So we just have to compute this quantity for the given transformations. So let us see how. In the first transformation, they are saying we are shifting our system QP from this basis to a newer basis, capital Q and capital P. So the value of Q is given to be this one and P is given to be this one, right? So this is the value which is given to us. So in order to check whether they form the canonical transformation or what or not, we check whether the Poisson bracket of these two quantities, it is equal to 1 or not. If yes, then we say that these two coordinates, they are canonical, and hence the given transformation is canonical transformation. So firstly, we'll apply the definition, and according to definition, we have to compute these four partial derivatives of capital Q and capital P with respect to small q and small p respectively. So firstly, let us calculate del Q by del small q. So this is del capital Q, right? So taking its partial derivative partially with respect to Q, cos P would be constant, E alpha would be constant, so we have to perform the integration, the derivative of square root 2Q. So it would come out to be this, right? Similarly, you can compute all other derivatives, and you'll see this 2 cancels with 2 over here, this cancels with this, e to the power alpha, and this becomes 1, right? So we are only left with p square cos square p, and here this minus minus becomes plus, this quantity and this quantity cancels, so we are only left with sine square p. So ultimately we'll get 1. So this comes out to be 1. That means we can say our transformation is a canonical transformation. So we got that this transformation over here, the first one, that is a canonical transformation. So similarly, we'll check for the other options also. So let us check for this transformation. Here Q is given to be, capital Q is given to be small q tan P, and capital P is given to be log of sine small p. So the canonical transformation, in order to check whether this is an canonical transformation or not, what do? We just check this identity, the Poisson brackets. So the formula is this one. Again, we just compute the derivatives. It is really simple, right? So you will see this term becomes 0, and here when you simplify this, this becomes cot of p. So tan p and cot p, they results in 1. So we again have this quantity equals to 1. So this transformation is also canonical. So second transformation is also canonical. Now it is left to check the third transformation to be the canonical transformation. So here this quantity over here, we need to check whether this is canonical transformation or not. For that, we again go for this identity. Just compute the derivative of this q firstly with respect to q, as there is no q, so it comes out to be 0. Then for the derivative of p with respect to small p, so it comes out to be q is constant, so derivative of p square is 2p, right, minus derivative of q with respect to p, here it is 1 upon p, so it comes out to be minus 1 upon p square, and the derivative of capital P with respect to q, so p square is constant, so derivative would only be p square, right, small p square over here. So obviously this cancels with this, and this term is 0, so we have 1 over here. So this transformation again comes out to be the canonical transformation. So here all these three transformations, they are canonical, therefore we say option D is the right option. Well, that is it for this video. I'll see you in the next video.